Alright, this is the Grandmaster video, carrying on for Chapter 9, Section 1. So we want to solve each system. So I have two systems here. This one looks crazy complicated. This one looks quite simple, but you'll notice that for substitution, it's not very friendly because each variable, okay, in both the equations has a coefficient in front of it. So it doesn't matter which variable we choose to isolate, we're going to have to divide out a coefficient. And I can tell just by looking at it, we're going to have to work with some fractions. So in this case, it really doesn't matter. So let's just, let's isolate y in the first one. So I'll just make a note of that. Isolate y in equation 1. Okay, that's if you want to label this as 1 and 2. All right, so this gives me 3y equals negative 2x, okay, minus 6. And then I'll divide out everything by 3. So that gives me y equals negative 2x over 3 minus 2. Okay, so that is equation 1 with y isolated. So now I'm going to substitute that into equation 2. So this y here is going to get replaced. So I'll actually do that in red. Okay, and I'll do that up here. So this is 5. Okay, so in blue we had negative 2x over 3 minus 2. Okay, so that's my 5y plus 7x equals 1. Okay, so I just rewrote equation 2 again, but I replaced this y with the y I isolated in equation 1. So you can see why this one is a little bit nastier. All right, so here I'm going to apply some distributive law. So this is going to give me negative 10x over 3 minus 10 plus 7x equals 1. Okay, now I'm going to solve for x. Now, I don't like these fractions. Okay, this is gross. So I'm going to multiply everything by 3. But in fact, before I do that, see this negative 10 here and the 1 on the other side? I'm just going to take care of that right now. I'm going to add 10 to both sides. Okay, that way it won't look quite as nasty. So I get negative 10x over 3 plus 7x equals 11. There we go, that's a little bit better. So now I'm going to clear out the fraction. So I'm going to multiply everything by 3. So it's easier to look at. Okay, so the 3's are going to cancel when I multiply this first term, so I'm just going to get negative 10x. And then from this one, I'm going to get plus 21x. And that is equal to 33. Okay, so negative 10x plus 21x, well, that's easily done in your head. That's just 11x. That's equal to 33. That has a very nice answer. Okay, divide everything by 11, and you get x is equal to 3. There we go. Well, we're not done yet. We've only solved part of the system, but getting the first answer is actually most of the work. So let's finish off by finding y. All right, to finish off, we need to solve for y. So I'm just going to create a little box here. Now to solve for y, I can use any equation I want. I can use equation 1, equation 2, it doesn't matter. But I would actually rather use my modified version of equation 1, because since it's y I'm looking for, y is already isolated. So y is equal to negative 2 times x, which I now know to be 3, all over 3, minus 2. Okay. Now yes, you could multiply this out, get negative 6, and divide by negative 3, but what's the point? 3 over 3 is just 1. So when these cancel out, you're just left with negative 2. So negative 2 minus 2 is negative 4. And there we go. So now we have completely solved the system. If x is 3 and y equals negative 4, both of these equations will hold. And I invite you, if you feel inclined, double check it. Okay, now the next one looks a little bit crazy, but it's actually not that bad, because before I try and apply any substitution whatsoever, I'm just going to do some algebra and just clean it up. That's really all I'm going to do, because I got a lot of brackets here. I can apply distributive law here and here. So I'm just going to, I'll do that work up here in case I run out of space. So this is going to give me 4x plus 4. Okay, plus 9 times 2, so that's plus 18 plus 9y. That is equal to 8. Okay, and I can clean that up even further. That's going to give me 4x plus 9y. Now I know that 4 plus 18, that's going to give me 22. But I'm going to subtract that 22 from both sides. Or in other words, just subtract 4 and subtract 18 from both sides. Right? Well, 8 minus 22 just gives me negative 14. Okay? So what did look crazy complicated is actually really not that bad. Okay? So let's do the same thing for this one. I'll do this one in red. So I can apply distributive law there, here, and here. So let's see what happens. So negative 2 times 3, I get negative 6. Watch your signs here. This is going to give me plus 2x. Next term, I just have plus 11y. That's fine. Minus 12 times 1, so minus 12. And minus 12 times y is just minus 12y. And we're told that is equal to negative 14. All right, so let's combine some like terms. So this is the only x term, so I'll just write that right now. It's 2x. And I have 11y minus 12y. Well, that's just minus y, or minus 1y. And then I have negative 6, and I have negative 12. Well, why don't I just add 6 to both sides and add 12 to both sides? So in other words, I'm just adding 18 to both sides. So negative 14 plus 18 on the right gives me 4. Okay. So suddenly, both equations, which in the beginning looked nuts, now are quite simple. Right? Now we can solve by substitution. Okay. Believe it or not, this one is going to be a lot easier than the first one. Because when you're solving by substitution, remember you have a choice. You can choose any variable from either equation and isolate it. But if possible, choose one that's easier. In other words, look for one that doesn't have a coefficient in front of it. Well, right here, okay, we have a minus, but so what? There's an invisible 1 hidden right here. So I would argue that this is the easiest variable to get by itself. So that's what I'm going to do. That's my target. So I'm going to isolate y in, this was equation 2, but my modified equation 2, my simpler one. Okay, this one is quite simple to isolate y. I'm just going to add y to both sides and subtract 4 from both sides. So that's going to give me 2x minus 4 equals y. That was easy. Way easier than this one. Okay. So now we substitute this in place of this y right here. So I'll keep the color consistent. So this gives me 4x plus 9y, but that y is really 2x minus 4. And of course this mess is equal to negative 14. All right, so this equation is easily solvable because it only has x's in it. So this is 4x. Okay, apply distributive law. So from here I get plus 18x minus 36 That's equal to minus 14. Let's combine like terms. This gives me 22x, and I'm going to add 36 to both sides, and that gives me 22 on the right. Isn't that convenient? It's convenient because we just divide both sides by 22. Isn't that nice? So x is just equal to 1. Okay? So we're almost done. We're not quite finished. We've done almost all of the work we need, but we haven't solved the system. We need x and y. So x is equal to 1. Now we can use that number using any equation we want. Now, I think it would be a bit insane to try and go back to one of the original equations. I would argue, let's go to this one. Okay, so this was equation 2, but rearranged for y so that we could isolate it. So that's the one I'm going to use. So this was 2x, but I now know x is 1. Minus 4 is y, and 2 minus 4 is just negative 2. So negative 2 is equal to y. Now our system is solved. So it looked pretty crazy. Actually really wasn't that bad. I prefer this one over this one. Use substitution to show that the system y equals 5 plus 2x and negative 4x equals negative 12 minus 2y has no solution. How do you know there's no solution? What would a graph of the system look like? Okay. Well, if a system has no solutions, when we graph it, we should see parallel lines. But what happens if we try and solve such a system using the substitution method? What would the algebra give us? Okay. Well, notice here, y is already isolated for us. So I actually don't even need to rearrange any of the equations. I'm just going to substitute this y value directly in place of this one. So this gives me negative 4x is equal to negative 12 minus 2y, but that y I'm going to replace with 5 plus 2x. So I'm just going to try and solve this equation for x. So this is negative 4x equals negative 12, and I need to apply distributive law. So this gives me negative 10. This gives me negative 4x. So let's combine all my x's. I'm going to add this 4x to both sides. So, that's actually going to give me 0x, or just 0. And negative 12 minus 10, that's negative 22. That does not make sense. Okay? So the x's completely canceled away, and I was left with a statement that is completely false. This is a contradiction. 0 does not equal negative 22. It never has, and it never will. Okay? So what it means is there cannot be a solution to this equation, okay, because it gives us something completely ridiculous. All right. It does say, how do we know there's no solution? What would a graph of the system look like? So here's a graph. Let's graph this thing and see what the picture would tell us. So this equation is very easy to graph because it's already in slope-intercept form. This one I'm going to solve for y. Okay, so that's going to give me 2y equals 4x minus 12. And then I'm going to divide everything by 2. So this gives me y equals 2x minus 6. Okay, so you can actually compare them now. Okay, this has a y-intercept of negative 6 and a slope of 2. So the line would look like so. Right? Here, I'll draw it in. Looks like that. There we go. And the other one, this one had a y-intercept of 5, but it also has a slope of 2. So that goes here, and rise over run moves like so. So I'll get my line in there. And sure enough, it's what we thought. Okay? We have parallel lines. There is no solution. So if you try it algebraically, you're going to get a statement that does not make any mathematical sense. A person tries to solve a system of linear equations using substitution. As they attempt to solve for the first variable, it completely cancels out, and the following statement remains: 3 equals 3. What does this mean? How many solutions does the system have? Well, if you think about it, it's almost exactly the same as number 2. The only difference is, after the variables canceled out, I was left with a statement that didn't make sense. It was untrue. But what if you're left with a statement that is true? Because after all, 3 does equal 3. Well, you're trying to solve a system. You're trying to find specific numbers for x and y. But if they always cancel out no matter what, and you get a statement that's always true, well, it means you have infinitely many solutions. It means you have infinitely many solutions. Right? Because it doesn't matter what x is or y is, they completely cancel out of the equation, and you're left with a statement that is always true. Okay. So visually, question doesn't ask for that, but visually what would we see if we were to graph it? Okay. If one of the lines, say, did this, okay, the other line would be right on top of it. Okay? I'll even give you an example. Why not? All right. Let's suppose I asked you to solve the system y equals x minus 3 and, I don't know, 2y equals 2x minus 6. Okay? Well, hopefully it's obvious to you that these are in fact the exact same equation. But let's say you didn't notice. Right? Let's say you just did this substitution directly and you used this y, because after all it is isolated, and you just replaced this one. Okay? Let's see what happens. So this would give me 2 times y, and I'll fill that in just a second. That is equal to 2x minus 6, and I'll just put this one in red. This was x minus 3. So I'm just doing a substitution as I normally would, but you'll notice something weird. You get 2x minus 6 equals 2x minus 6. So if you try and collect all the variables on one side, you get 0. And if you add 6 from here to both sides, you get 0. Right? So you actually get 0 equals 0. That is true, 0 equals 0, but that didn't exactly help us find any specific solutions. Okay? Because if you look here, the lines are exactly the same. Okay? So we would see two lines right on top of each other, infinitely many solutions.